Hey guys, my name is Trevor Sullivan and welcome back to my video channel. In this video, we are going to be continuing our learning about LXD, specifically the import and export operations that allow you to export virtual machines as files on the file system and make them portable between different LXD hosts, create backups in object storage, or really do whatever you want to with those backups. But before we get into our topic, please remember to like this video, subscribe to the channel, share a link with your friends, family, and professional contacts, and leave a comment down below and let me know what other kind of topics you want to see on this channel and what you think of this video. Also, make sure that you check out the open source software playlist, as that is where I'll be adding this video to, as well as the other LXD videos that I've already created in this series. There should be a link in the description. All right, so let's move on and talk about this topic. Now, this is going to be a pretty quick topic because exporting and importing LXD virtual machines is a pretty straightforward operation. All you need to do is just practice with it for a few minutes and understand the key use cases where this is a particularly useful feature in LXD. So let's kind of talk through a diagram for starters that describes the purpose behind why this operation is available in LXD. So let's just say that we have a single standalone LXD host. It's called LXD 01. We've got LXD running on Ubuntu Linux here. It's really up to you what Linux distribution you want to use, but I generally just use Ubuntu for ease of use. And then, of course, we typically have a default storage pool that's going to use the ZFS storage pool driver. I've got a separate video that actually talks about storage pools and how they work. But when we create a virtual machine, it's just going to go into that default storage pool. So its root file system volume is going to be created inside of that default storage pool. Now, this is nothing new so far. We've already been through the process of creating virtual machines on LXD hosts. However, the real benefit here is that we can create a backups folder, and we can export our virtual machine, which is called U01 here in this case, to this VM backups folder by using the LXC export command. Now, LXC export is a really simple command. There are a couple of optional arguments or parameters that you can pass in to the export command, but all you really have to specify is a name of the virtual machine that you want to export on the LXD host. Now remember that LXC and LXD work together, LXC being the command line tool and LXD being the service that's actually running and managing your virtual machines. And the LXC utility could be running on a remote client. So it could be running on your dev laptop, it could be running on a physical workstation, or you could actually be running it directly on the LXD host. So when we run LXC export or import operations, always keep in mind where LXC is running and not necessarily where the LXD host is. However, in my examples, I generally do run LXC against the local host, and in a separate video, we'll talk about how to set up remotes so that you can actually use LXC from a remote host to manage LXD engines. So there's a couple of other iterations of the export command that are available. One of the options here is to specify a file name for the backup that you want to create. That's not really that important because once you take an export, you can very easily just use the Unix command line utilities to rename a file. So you could just use the mv command or the cp command to either move or copy the file to a new file name or different directory, but that is another optional parameter that you have. Also, if you'd like to, you can specify the compression level over here, and this isn't very well documented, but I did find on the Linux containers discussion forum that you can actually specify the path to gzip and then specify the -1 through -9 arguments in order to specify the level of compression. So -1 would be lowest compression, but highest performance, and -9 would be slowest, but it would give you better compression. So once we've got a backup, what can we do with it? Well, one option that we have is to copy that backup file to a different LXD host. So let's say that we have a second bare metal system that's running the LXD engine. We could simply copy that tar gzip file over to the other host and then create new virtual machines from the backup that we took of a virtual machine on the LXD 01 host. So that's one option, is to copy between different hosts, but another really cool option that we have is actually to move virtual machines to different storage pools. So back in our video about storage pools, we talked about the different storage pool drivers that are available. But in this case, I'm going to just kind of cover the directory storage pool driver. So we could create a new storage pool, maybe on a separate physical disk. And then what we could actually do is take the backup of this U01 virtual machine and actually restore it to a new virtual machine that's running on a different storage pool. And the way that we can do that is by using the import command to specify which storage pool we want to import the virtual machine to. Now, the storage pool called file01 here doesn't exist by default. Only the default ZFS storage pool exists by default. And so we'd have to create a storage pool somewhere else and specify the driver, but that's pretty easy to do. And if you want to learn how to do that, go watch my other video on storage pools. But this is a really useful capability because if we accidentally create a virtual machine like U01 right here and put its root file system on a disk that's going to be too small for the long term, and then we spend hours and hours customizing U01 by installing software, applying configuration files, and all that fun stuff, and we start to realize that we're running out of space on our default storage pool, well, we can simply take a snapshot or export of that to a file, and then we can import it to a new virtual machine, and then we can go back and destroy the original virtual machine, and that way we've successfully migrated it to a new storage pool that has extra disk space for the purpose that that virtual machine holds. So the way that we can import a virtual machine from a backup here is pretty straightforward. All we need to do is specify the file name to the tar.gzip file that we want to import. And then the other options we have are, of course, to specify an alternative remote. So we could take a backup file that we have on our local development workstation and restore it to a different LXD host that we've configured as a remote in the LXC CLI. And then we also have the ability to specify a virtual machine name that we want to restore to. So I could take the backup here from U01 called u01.tar.gz, and I could restore that to a virtual machine with the name U02, U03, or whatever other name that I wanted to give it. All right, so now that we understand the purpose of export and import and how it works, let's talk about some different tasks that you can practice on your LXD host to make sure that you understand how this feature works and just how it works in general. So the first thing you want to do, of course, is just to take an export of an existing LXD VM. So you'll just launch a new virtual machine, do whatever customizations you want to on it, and then take an export of that. And then you can also just import that to a new virtual machine. So you take that tar.gzip file, restore it to a new VM, perhaps with a different name, or if you deleted the original VM that you took a snapshot of or an export of, you could just go ahead and restore it to a VM with the same name. Also, you can practice moving your virtual machines between different storage pools by creating a secondary or tertiary storage pool, and then take an export and import to a new virtual machine specifying the different storage pool name. So now that we understand some of these different practice tasks, let's go ahead and jump into our terminal where we'll actually take a look at how this feature works in practice. So I've got a LXD host right here, and if I run sudo lsb release --all, you can see I'm running the latest LTS version of Ubuntu Linux here. Also, if I do LXC version, I'm running version 502 of LXD here. And so that's kind of what my environment looks like. Also, you can see I don't currently have any virtual machines configured. And if I do LXC image list, the only images that I've downloaded are the desktop version of 23.04 Ubuntu and the server image for Ubuntu 23.04 Lunar Lobster as well. And you can kind of tell, even though there's not a description that says desktop or server, you can kind of tell just based on the size of the image that the 1.2 gig image here is the desktop operating system, and the much slimmer 300 meg image here is the server distribution of Ubuntu Lunar Lobster 23.04. All right, so to practice with the import and export operations right here with LXC, you can see we've got export and we've got import contexts right here. What we're going to do is just start by creating a new virtual machine. Also, I did want to show you my storage pools. So just really quickly, I only have my default storage pool right here, and it looks like it's using the directory driver. So what we're going to do now is launch a virtual machine by doing LXC launch --VM, and then we'll specify our image that we want to use. So I'm going to use the alias on the default images server of Ubuntu/23.04. That's the image that I've already got cached locally. And then I'm going to specify a VM name like U01. And because we've already got that image downloaded, it's going to be very quick to create a new virtual machine. And then we can exec into the virtual machine and get an interactive shell so that we can install any software or make any customizations that we want to before we take an export snapshot of the virtual machine's state. So once that virtual machine comes up, we'll go ahead and run LXC exec to get a shell on that VM. All right, so now our U01 virtual machine is up and running here. And what we're going to do is just exec into it by doing an LXC exec and then say U01 -- bash. And as soon as the LXD agent comes up, we should be able to get an interactive shell into our VM. Once we've got our interactive shell here, we can go ahead and run standard commands like apt update and apt upgrade -- yes, and maybe install some software packages like the Avahi daemon. And I like to make sure that Vim and snapd are installed as well. So, maybe I'll just specify snapd there. So this will kind of prepare our base image that we want to then export later on and build new virtual machines from. Also, you could periodically set up a cron schedule that automatically takes snapshots or exports of your virtual machine and then scripts the uploading of those exports up into some kind of cloud object storage so that maybe you could have an offsite backup of your virtual machines on maybe an hourly basis, a daily basis, a weekly basis, whatever kind of interval makes the most sense for you. So think about the different things that you can do once you've already taken those exports to those tar gzip files of your virtual machines. All right, so now that we've got some customizations applied right here, as soon as snapd finishes installing there, we could maybe do some snap package installs as well, but I'm just going to leave it at this for now. So you can apply any additional customizations that you'd like to. We'll exit out of our interactive shell from that virtual machine. And now what we want to do is actually shut down the virtual machine so that we don't have any processes running. So we'll do an LXC stop on U01, and typically they stop pretty quickly depending on what you've got installed there. As you can see, my Linux server here stopped pretty quickly, and now we're going to take an export of this virtual machine with all of its customizations. So as you can see, we can do LXC export. The only required parameter here is the instance name or virtual machine name, as I like to call it. You can also specify the remote, but in this case, we're just using the implied local system instead of specifying an alternative remote. And then we also can specify a file name that we want here as well, if we'd like to. So let's do LXC export U01, and I'll just call it u01.tar.gz. And then I can also add on this compression parameter and say gzip-2, and that'll give me just one step below the fastest version of compression for gzip. Now, depending on how large your root file system is, this will take more or less time, but of course in this case we haven't really installed all that much software, so hopefully the export won't take very long. All right, so just after a few seconds here, I've got a full export of my system. And if I do ls-lga right here to get a long list format, you can see that I've got my 490 megabyte file right here as a tar gzip file. So now that I've got my backup or export of my LXD virtual machine, I could copy that to a different LXD host and import it if I would like to, but I don't have another LXD host to work on at the moment here, so we're just going to use the local one to import it instead. So let's take a look at the import operation right here. If we do an LXC import command, you can see again that the only mandatory parameter or argument here is the backup file name. However, we have the optional parameter here as indicated by these square brackets that allows us to specify a VM name that we want to restore to. And once again, if you have a remote LXD engine connected to your LXC CLI tool, you can specify that remote as an optional argument as well. But if you don't specify the remote, then it just assumes that you're talking to the local LXD socket. All right, so let's go ahead and try this out. Also, you'll notice down here we've got -- storage if we wanted to specify a pool name, but for now we're just going to use the single pool that we have. we do LXD Storage List, we just have our default pool right down here. So let's go ahead and restore to a new VM name. So I've still got my U01 VM here. Granted, it is stopped, but I'll go ahead and start it up just so it can be sitting there running in the background. And so we'll do LXC import, specify our file name, which is u01.tar.gz, and then we'll specify a different VM name like u02. And what that'll do is it'll unzip the archive file here. It'll create a new root file system for our new virtual machine, and it'll go ahead and spin up this new U02 VM so that we can use it. So this is kind of an alternative mechanism to storing images internally in the LXD engine. Because it's just a file, we have the ability to take this exported image and copy it to any LXD host that we want to, or just create new VMs from this archive on the local LXD engine. All right, so our import operation has succeeded here, and if we run LXC list, we should see our U01 VM that's running here, but we also have this new one called U02 that's in the stopped state. So let's go ahead and start U02 as well and get it up and running. We can also take a look at our volumes in our storage pool. So let's do LXC storage volume, and then we want to list our volumes in the default storage pool. And as you can see, we have two VM rootfs volumes, U01 and U02, both in this storage pool here. So let's go ahead and see if we can exec into it. So we'll do an LXC exec and then do U02-bash. And we should already have the Avahi daemon as well as the Snap Package Manager pre-installed because we installed that before we took the snapshot of U01. Also, you'll notice that because we took a snapshot of U01, even though we exec'd into U02, the host name was actually persisted. So you would probably want to change the host name to something that's unique to avoid any naming collisions on your network. And to do that, you can just go edit the hostname file. So if you go into etc/hostname, you can change the name of the virtual machine to something like U02 instead of U01. And after we reboot, that should take effect permanently. All right, so let's check if our software is installed. So we could do systemctl status on Avahi daemon. As you can see, it is installed and it's actually active and running. And then also we should be able to use the Snap Package Manager to install software. So if we try to run something like snap install btop, that should invoke the Snap installer to download btop and get that installed on our system. And sure enough, it's working just fine here. I'm just going to hit Control-C to cancel that because I don't care about actually installing it. I just wanted to validate that Snap was actually installed. All right, so now what we can do is take a look at how to restore the export to a different storage pool. So remember that right now we only have our default storage pool, which is using the directory driver. But what if we wanted to create a new storage pool on a different file system location? Well, for starters, we could create a folder like /data and then /files01. And let's say that we wanted this directory here to be our new location for a storage pool. It could be a different disk, for example, that has more storage or maybe faster storage. But let's say that we actually wanted to take a VM and create it on that new storage pool from the export. Well, what we can do is create a new storage pool by running LXC storage create. And then we need to specify a pool and a driver name. So we'll do create and we'll call it files01 using the directory driver, and the data source will be /data/files01. So now if we do an LXC storage list, we should see that we have a second storage pool configured here, and we currently don't have any virtual machines in that secondary storage pool. However, thanks to the import command right here, we have the ability to specify the -- storage parameter, and that allows us to tell it which storage pool we want to import a backup of a virtual machine into. So if we say LXC import U01, and then we'll restore it to a new virtual machine called U03 because we already have U01 and U02, and then do -- storage, and set it to the files01 storage pool, that will actually take that U01 export, import it to a new VM called U03, but the rootfs volume of U03 is now going to get created on the custom storage pool that we specified here. So let's give this just a second to finish importing. All right, so our import has finished here, so let's go ahead and double check our storage pools here. And as you can see, the files01 storage pool is now being used by one virtual machine or one volume right here. So now if we do an LXC storage volume list on the files01 storage pool, you can now see that the virtual machine called U03 now has its root file system as a block device inside of this custom storage pool. So if we run an LXC list right here, we should see our third virtual machine imported right here. And it's currently in the stopped state, but we can go ahead and just do an LXC start on U03. And just like that, we've been able to take our export and duplicate it or replicate it to two new virtual machines across different storage pools. So again, the export and import operations are pretty simplistic in nature, but it's really good for you to get some hands-on time with this capability to ensure that you understand exactly how this functionality works, especially when it comes to specifying custom storage pools here. Anyways, I hope you enjoyed this video and that you learned something new about LXD or Linux in general. Thanks again for watching. Leave a like, leave a comment below, check the description for additional links, and we'll see you in the next video. Take care.